Hello, welcome to Platform 2024. This session is on containers, container management systems, APIs, and how to leverage them to make your life easier. I'm Dave Demlow. I'm the Vice President of Product Strategy here. What we're going to talk about is automation in general, things like infrastructure as code, talk about our REST API, the Ansible collection for scale computing hypercore. Then we're going to talk about containers, different kinds of container runtimes, container orchestrators, talk about Docker versus Kubernetes. We're going to do a demo, actually two demos. One, we're going to deploy using automation a new virtual machine with a Docker runtime and a Docker Compose application. And then we're also going to deploy do automated deployment of a MicroK8s Kubernetes cluster and an application there. And then we'll talk about some advanced topics like multi-node Kubernetes and systems for updating your application infrastructure like GitOps and connecting into CI/CD pipelines. Why does this matter? Well, because there's a lot of things that go into managing infrastructure and applications over their entire life cycle. A lot of automation, we may just think about the initial deployment, setting up the hardware, setting up the software, configuring it, the things that you might do, day zero, day one to get up and running and provide a new application. But there's a lot more that goes beyond that. There's, things like monitoring your application, performance metrics, handling failures. Thankfully, most of you have a resilient SE platform infrastructure that's handling a lot of those things for you, but managing updates to the infrastructure, to your applications, and so forth to handle rapid security responses, things like that. And then increasingly, we're seeing, the expectation from the business that the IT organization should be able to respond quickly to demands for new applications, whether those require completely new resources like GPU or AI/ML type applications or simple line of business kinds of applications. So this is all about looking at the entire application lifecycle and taking a look at it from a new way. With automation, and the reason that it's important is it allows you to do all these things like increase the speed and agility of not just initial deployment, of deploying new applications, of expanding, making changes to the system, patching, all those kinds of things that require testing, thought, being able to standardize those and do those in a much more repeatable way, reduce errors, enhance your security posture, and ultimately lower costs and provide higher reliability for your applications that you're providing to your business users. So SE Platform, everyone here should be familiar. It's a platform and a system for managing applications, whether they're modern, containerized-based applications that we'll spend a lot of time here on, or legacy applications running in virtual machines across an entire ecosystem that can be, multiple edge locations, centralized data centers, but providing that whole platform for managing and running your applications regardless of what your needs are. So, it's getting into automation. Really, a key for the ability to automate this is the Hypercore REST API, and this is available on every cluster. A lot of people don't know that it's there. It's actually the documentation is built right into the Scale Computing user interface. It provides the ability to basically automate and control and script, or for third-party applications, like we'll talk about with Ansible, to integrate directly into Hypercore, make changes. Anything that you can do from the user interface can be done through the API. And here, a lot of the things we're talking about is being able to mass provision customized VMs. So you can save time automating the manual steps, and we'll show you some playbooks here where we, in the demo, where we go through the manual steps that you have to do to deploy a new application or deploy an operating system, and in the process, reduce human error, get deployment consistency, and then make change control much easier. One of the key things that was added fairly recently in the last few years to the REST API is the ability to pass what's called cloud init information into the virtual machines on creation. So what this lets you do, and it's a standardized format that most operating systems support, basically lets you pass all the information about what that virtual machine should do. So things like, what name should it have, what IPs, what users should I create, what applications should I run, what packages. We'll get a good example of that in our automated deployment demos. So this is really a key piece, and allows access to the cluster using all sorts of programmatic tools, and then scripting tools like PowerShell, Python. For what it's worth, as I mentioned, it's available in the documentation is available in the product in a navigable way. If I get time, we'll show you a little bit of that here. And then we also do have examples online on our public scale computing GitHub repository of common VM workflows, things like that. The REST API was one of the things that enabled us to build a very specific scale computing Ansible collection. The Ansible collection uses the REST API, but Ansible makes things much more easy to create new playbooks. They're much more human readable, and it's particularly good when it comes to ongoing configuration management. So creating playbooks that I want to be able to run this over and over, see if there's been any change to my configuration, correct that. Also particularly good when it comes to being able to do automation across a large number of sites. I'm going to do some demos here where I'm just running and creating one VM on one cluster, but that same playbook that I'm going to run and basically the same command I'm going to run, I could very easily say, do the same thing on 1,000 clusters if I have access to them. And so Ansible is a great tool when it comes to that. And then also it's an open source tool, and there's large collections of other third-party software, hardware, clouds, network systems that can be managed by Ansible. So automation that you can do with Ansible doesn't just pertain to SC Hypercore. It also can pertain to directly the virtual machines themselves, or things like Docker or Kubernetes inside there. There are collections that manages all those things, and then also other ecosystem dependencies like networking and so forth. So let's move on to containers, and we're not going to go super deep. There's lots of great stuff available, but high level, we'll talk about running containers inside virtual machines versus running containers on bare metal, and some of the differences and the benefits. So on the left here, we're showing virtual machines. So obviously we have your physical servers, in this case, your physical Hypercore nodes. On those, there's an operating system. In the case of SE Platform, that would be the Hypercore operating system, which includes the hypervisor components and also the storage layer and everything that you need, the management tools, the web user interface, so on and so forth. And it's a platform for running virtual machines. So when in the case of running containers on Hypercore, you still get all the benefits of isolation that you get with virtual machines. And as we'll show here, you can deploy containers simply by deploying virtual machines with a guest operating system. And there's lots of guest operating systems that can be configured to be very container-oriented, container-efficient. Inside that guest operating system, you would deploy a container engine. When you hear about things like Docker, could be considered a container engine. Also things like Podman or Containerd. There's several actually that are out there besides Docker that can all run OCI compliant containers. So you would deploy a container runtime. Generally, Docker is one of the main ones. And then your applications deploy and run as a container on top of that container engine. And as you can see kind of here on the left, you can have multiple containers that are sharing that same container engine, that same guest operating system, and they can communicate with it and so forth. Same thing is certainly possible to do on physical bare metal. You could install your physical server. You could put a Linux operating system on bare metal, deploy Docker directly on that, and then run multiple containers on that bare metal server. But with containers, you don't get things like live migration. You don't get the same portability. You can't run virtual machines side by side with container operating systems. So in virtually all large scale environments, including public clouds, when you're running containers, including when you're running Kubernetes, it's best practice to put those inside virtual machines for isolation, and then for all the benefits that you get of being able to run those on a managed resilient platform like Hypercore or a public cloud. So some of the terms you may hear, touched a little bit on, Docker is a container runtime that's used to create, build, and run containers. It's just one of many available OCI, Open Container Initiative is the acronym, container runtime or engines. I mentioned a couple others. Kubernetes is actually what's considered a container orchestrator that coordinates running containers generally across multiple nodes, and it can work with multiple OCI container runtimes, including, but not today, commonly Docker. So when you have a Kubernetes cluster, it has its own container runtime that would get installed, but it's running those same OCI containers. You could build your containers using Docker tools if you wanted, and then to configure those to be deployed on Kubernetes. But Kubernetes, you generally would think of as its focused on deploying groups of containers, multiple containers, handling the connections between those containers, handling access to other services like storage, and then also across multiple physical nodes. Is something that's kind of a native capability built into Kubernetes. It's not uncommon in clouds to have 1,000 node Kubernetes clusters that are deploying large scale distributed applications. Whereas Docker, while there is a form called Docker Swarm, where you can have multiple Docker servers kind of connect and collaborate together, it's fairly uncommon to be used. And generally, when you generally go to Kubernetes when you're talking about those kind of more complex applications that you want to run. So again, Kubernetes is just another way of running and orchestrating containers. It has some different concepts. So you've got a bunch of containers that, collectively may define an application. Those are configured into pods, which would have multiple containers that are part of the same application. And pods are kind of a concept that can be scheduled by a Kubernetes cluster, whether it's one node. Here on the right, we're showing, a multiple node Kubernetes cluster. These would all be virtual machines. One might be what's called a master node, or it's the control plane. Other nodes might be worker nodes that are just running pods, running group of containers that are scheduled by Kubernetes. And for applications that can be load balanced, which are often stateless applications behind a load balancer, you can also, with Kubernetes, kind of scale up or down an application by setting how many replicas of pods you want to have running. Say you have a front-end web server that's defined as a pod, you can set a value in Kubernetes and say, I want 5 of those, and I want to scale it up or down and put it behind a load balancer and automatically scale out that application within a single node or across multiple nodes. It just depends on the case. So those are the kinds of capabilities that are built into Kubernetes versus just simple Docker runtimes. Kubernetes also has a very established ecosystem. There's a standard Kubernetes API. There's an organization called the CNCF, Cloud Native Computing Foundation, that owns and standardizes Kubernetes and the ecosystem of the API and so forth. Kubernetes, you'll often hear being discussed about different Kubernetes distributions. Think of it kind of like a Linux distribution. So some package of Kubernetes codes that has kind of that core control function and scheduling supports the Kubernetes API, but then may have other services that are available. And in some of those cases, those can tend to be what you may hear referred to as opinionated services on how does it handle networking plugins, how does it handle storage or things like that. But very common Kubernetes distributions that you'll hear about, and we often hear being deployed. K3s is a very popular one. It's open source. It's created by Rancher, which is owned by SUSE. MicroK8s is another lightweight, very easy, relatively Kubernetes distribution that's kind of sponsored by Canonical. So you tend to see this in an Ubuntu, Debian kind of ecosystem. Minishift is an open source version of Red Hat OpenShift, which is their managed Kubernetes distribution. And then you'll find many that are more cloud focused, and I would put Red Hat into this case. You can, in all these cases, deploy some versions or attach some versions of Kubernetes from on-prem up, but Google Anthos, for example, Google's the creator of Kubernetes. Anthos is their managed, opinionated Kubernetes application stack. It's based on GKE, which is Google Kubernetes Engine, but they do have a mode that can be run on bare metal or inside virtual machines. And we have another session that I've done here where I talk about hybrid cloud and show examples of, for example, Google Anthos clusters running on HyperCore systems, multiple of those being run on premises, but connecting into the Google Cloud control plane, for example. Okay, for the demo portion of this, we are going to have to go through it pretty quickly, but we're happy to spend more time, individually and go through these in more details. But what we're going to do is use automation to deploy a Docker virtual machine runtime with some applications as well as some MicroK8s. And we're going to do that using Ansible. So I'm going to go ahead and kick these off and then we'll talk. So I'm going to run an Ansible playbook. I'm specifying basically data variables from my inventory, but specifying the cluster I'm running against and the playbook. So let's go ahead and start this off. This playbook, for what it's worth, you can see this is the Docker Compose portion that I'm passing into just a standard vanilla Ubuntu cloud image. So I'm using cloud init, passing all the information into this virtual machine. This playbook actually is available online. I'm just specifying, like I said, a standard of Ubuntu cloud image. It is deploying this virtual machine onto this particular cluster here, passing it everything that it needs to configure its name, its host name, create the Docker containers, install and properly configure Docker. So we'll let this run for a second. And then because we also want to deploy micro-K8s, let me go ahead and that was the Docker. I'm going to run another playbook here that I have that basically does the same thing, creates another VM, but it's installing and configuring micro-K8s and some applications. So let's go ahead and get that off and running. And again, just a little bit on Ansible. So I'm running these playbooks. When you see green and OK, that means it ran a step it didn't need to do. So this playbook would automatically go to a public website from Ubuntu, download a cloud image, put it onto the cluster, create a template VM. All that stuff's already been done. So that really, when I execute these playbooks, when you get to the point of actually creating the customized VM, that's where you see action starting to happen. And so we can see this Docker VM's already created. The micro-K8s VM is spinning itself up. But let's go ahead and take a look at the Docker VM. I'm going to log in. And we'll take a look at the Cloud Init. We'll watch the output. And what we can see here is it's actually pretty far into the Cloud Init. If I'm looking at it, it's actually, spinning up containers. In this case, we were deploying a WordPress application onto this virtual machine. And again, all of that was specified automatically using Cloud Init. So I didn't have to, I could have done this manually. I could take and install Ubuntu from an ISO image. I could then install Docker packages. I could, create my Docker Compose or copy that onto the cluster or whatnot. In this case, I was able to do it all via automation. So that if I wanted to deploy a bunch of these or deploy these in different locations, or I want to make a change and just redeploy the application or the entire VM, I can do that. I could do other things, like maybe there's certain tools or company policies for how I configure the virtual machines that can be all built into your automation and so forth. So some of the great benefits of automating. All right, so our playbooks are all done. This virtual machine is done. So when it gets to this data source, no cloud, I know that that's the end of the Cloud Init. So let me just run a command, Docker PS, sudo Docker PS. And we can see that, okay, I'm running 2 containers here. And actually, if we let's take a look over at our micro-K8 to see where it's at and its deployment. I'm going to go ahead now and reboot this. Both of these, I have a command in there that changes the resolution. So it'll be, especially on the micro-K8 side, a little better to be able to see that. Yeah, so we can see our containers running here, and then we have an IP address. So let's go ahead and I just went to expose the WordPress application I deployed on port 80. So all I had to do was kind of go to the default ports, and I've got WordPress, in this case, a multi-container application up and running over here. And I'm all good. And I can, again, redeploy it. I can, SSH into this VM. I could use Ansible to automate and connect into this VM and make any changes or things like that that I want to do. Let's take a look at our micro-K8s. At this point, we should also be done. Let's do micro-K8s, kubectl, nodes. I think I do have to sudo. So we can see that I have a node here all configured, and let's do get all. We'll just take a wide look at everything that's on this cluster. So it's a single node system, and it looks like there's still probably some pieces that are being deployed at this point. But I can see a number of different, pods. Yeah, we can see things are still spinning up on the Kubernetes side here. And part of my original deployment actually was I deployed some applications, including a Portainer agent, a security agent that I wanted to have in here. And those are all, again, part of the application. But just that easily, I spun up a Docker runtime virtual machine, deployed some applications, spun up, in this case, a single node micro-K8s node, and I could easily spin up more and connect those into this if I wanted to create a multi-node Kubernetes cluster. So that's our demonstration. Thanks. So those are our two demonstrations. So let's talk about multi-node Kubernetes. First of all, the question is, do you need to cluster, which is what Kubernetes generally is, or multi-node, on top of something that's already clustered? Do you need it for availability? Do you have an application that actually needs to, from a resource standpoint, to span or distribute load across multiple physical nodes or network interfaces, things like that? Or can you just create one VM that's big enough to do what you need? It depends. There's different kinds of applications, and but one thing we do find is, very often you don't. Very often a single node Kubernetes cluster is just fine. Another related thing is, well, what if you have multiple Kubernetes applications? Should you put them all in the same cluster? Should you put them in separate namespaces on the same cluster? Sometimes the answer is yes. Sometimes, maybe if they're two completely different applications, maybe different development teams, maybe what you want to do is keep them totally separate and have one single node Kubernetes cluster for application one, a second single node Kubernetes cluster for application two, so you can update the Kubernetes versions independently or things like that, have flexibility. And again, a single node Kubernetes cluster running in a VM on HyperCore has persistent data redundancy automatically built in based on Scribe. It has automatic failover. It has live migration. So, as the infrastructure is being updated, we can move that Kubernetes cluster, that single node cluster around. So it's a question, and there's pros and cons to both, and certainly both are supportable. There are some simplifications, like you saw here. It's very easy to just deploy the one VM, give it everything it needs. I could also have a playbook that deploys 3 or 5 VMs, clusters them together. Now I do need to have more information about the networking and things like that. So there's pros and cons. Storage. A lot of the applications that have been refactored to run in containers, to run on Kubernetes, are basically stateless or fully stateless in a lot of cases. If it's a part of your application that's designed to run behind a load balancer, and where I might run 5 front-end web servers, and all they're doing is reading config from something else, maybe stored in object storage or on an external database. That's a stateless application, and it doesn't need any storage for those particular pods. But beyond that, Kubernetes does have the ability to use local storage. So every Kubernetes node, you can expose its local storage, which again is protected by Scribe, and have that available to that particular node. There are some issues in that case, for example, with pure local storage. If there are containers that are required to use that storage, they generally would be limited to running on the node where that storage is provisioned, and Kubernetes would take care of all of that automatically. So that may be totally fine. A lot of those applications that do use persistent storage, like I mentioned, may use external storage. And this is particularly true if it's an application that requires shared access to the shared data, or read write many. RWX is a storage class terminology in Kubernetes. And generally there, you're talking about, maybe what you would do is deploy an NFS server VM that is your shared storage, and then configure your Kubernetes cluster to consume storage from that, or maybe deploy some type of object storage solution in a VM, containers. There's an open source project called MinIO that provides object storage. It's basically AWS S3 compatible storage that you can run locally. You can put in a VM, you can run as a container, or in some cases we see external databases as well. There are also native distributed storage products that are built in to run inside Kubernetes. And if you had multiple Kubernetes nodes clustered together running inside HyperCore, you certainly could use those same tools. And some of the ones that you might hear of are OpenEBS. Portworx is a commercial product, or Longhorn. These are software-defined storage products that are designed for Kubernetes, that run in Kubernetes and are controlled by Kubernetes. And you could run those inside Kubernetes clusters that are also being hosted on top of HyperCore. And it's just extra redundancy. You can think of it, that way. But so again, you have to think about your use cases. Do you have applications that require scale out load balancing? You can also start with one node Kubernetes and expand it later down the line. And then the downside is, the increased complexity, increased resource usage of, having multiple Kubernetes nodes running. There is more overhead communication of keeping those in sync, and so on and so forth. So it's just a fair question to ask for your applications. So let's talk about, other methodologies. And here we are going to preview a little bit, or at least talk about some concepts that these are things you can do today that we are building into SE Platform as kind of native capabilities over time. We talked about infrastructure as code, using Git or version control systems to store configuration management along with your application code in many cases. Where CI/CD, and that's commonly referred to as GitOps, when you're controlling your application and your infrastructure using, version control system, using Git, type version control. CI/CD stands for continuous integration, continuous deployment, and that's a model that's designed to, instead of big, massive, once a year upgrades of everything, build a system that's designed to be continuously integrated as changes and then continuously deployed. Those kind of go often hand in hand. If you want to do that, you might use, a Git version control system where you're making your changes, you're checking those in. Part of the continuous integration should be automated testing where possible. So as you make these changes, you're first automatically deploying them to lab environments, or maybe, starting there and verifying that the infrastructure, the applications still are performing as expected. And then potentially even on the continuous deployment side, deploying them in pieces, doing continuous deployment, what's often called canary deployment, where, all right, now we're going to deploy in, a handful, 10% of our remote sites and verify that those are good before we, piece by piece deploy the rest of our fleet. So those are concepts that are, again, available today. But I will preview, they are concepts that we are looking at building in to future versions of SE Platform, and building into, for example, Fleet Manager, where you could, through Fleet Manager, define an application, point us to the Git repo or the source of truth for that application, and then have SE Platform through Fleet Manager down to HyperCore utilize that information with some additional tools that we're building to apply that orchestration, apply that automation on a continuous basis built in. And so that's something, if you have interest in learning more about that and working with us, to giving us your requirements for the development of that, reach out to me or anyone on our product management team. We would love to talk to you more about what's coming in that area. And when it comes to containers, again, this is a different ecosystem. So, Scale has already spent a lot of time making sure that we can work with not just, the infrastructure platform and the applications and the IT team, giving them the control, but we do increasingly see application developers, and in some cases even external development teams, as being, a first-class citizen, a team that is going to be part of this whole application ecosystem and life cycle. So we have been working with, and there's another session that talks about hybrid cloud, how we can interface with a variety of third-party container management systems, whether they're, Azure Arc, Google Anthos, I've mentioned, AWS, Elastic Container Service, third-party systems that we partner with, companies like Avasa, Control Tower, Portainer. There's a whole bunch of systems out there that can be the control plane for application teams to develop their application, push things out, make updates, get telemetry. We want to make sure we work with those, as well as providing, the basics right out of the box, without necessarily needing any of those. But if you have teams that are already, they have a set of tools they want to use, rest assured that, they can continue using those tools, and we can still integrate them into this entire ecosystem. To kind of pull it all together, what we really are trying to do is provide cloud-like management for distributed systems all the way out to the edge. So, in the cloud, a lot of people you didn't have to worry about the hardware underneath. You often didn't have to worry about the operating system that's running there, or the hypervisor. Trust me, it's there, and there's an operating system that's running, underneath your Kubernetes cluster, or running underneath your container runtime. But the cloud, because of its central location, was able to hide a lot of that. In, on-premises IT and especially distributed IT, somebody has to own that, and the enterprises and the service providers own that. And so we want to provide that same kind of management, make the hardware as simple as possible, make all that, software stack underneath it as well managed through automation, high availability, easy to use, easy to scale out as possible. And that's where we're focusing on. And we certainly happy to work with you today on setting up automation and deploying these new applications. And as I mentioned, would love to work with you and make sure that we are the best platform for your applications going forward as well. So thanks very much for your time.